ready to dive deep. Today, we're exploring the life and discoveries of Edwin Hubble, a figure who, well, basically changed how we see the entire universe.
Yeah, his impact is still felt in cosmology today. Really foundational stuff.
Exactly, and we do like to get into the nitty-gritty here, so we're going deep into a Spanish-language biography of Hubble, which is pretty interesting in itself. We'll uncover not just his big scientific findings, but also the man behind the telescope.
The person, not just the science.
Right. His quirks, rivalries, all of that, and how the world around him shaped his work.
Always crucial to consider that human element in science, I think. Discoveries don't just appear out of thin air.
Totally. And you might be surprised to hear that Hubble was quite the character. I mean, imagine this. Brilliant astronomer, star athlete, bit of a showman, and completely in love with British culture after his time at Oxford. That complexity really played a role in his journey.
Oh, he went all in on that, even adopted a British accent and everything. Didn't always go over well back in the States, even with his family. Science was his priority, sometimes to the detriment of his personal life.
It's fascinating, isn't it? Like, there's this pattern of him exaggerating accomplishments, not just athletics, but military service. Even his legal career points to real ambition.
Yeah.
His need to stand out.
Well, stand out he did, though maybe not always how he claimed. What's really interesting is that for all his scientific fame, Hubble's path to astronomy was anything but straightforward. Started off studying law, to please his dad.
Almost like a detour on his path to the stars.
Exactly. He found his way to astronomy eventually, but even then, his formal training in the field was pretty limited. Relied a lot on natural talent and a huge thirst for knowledge to guide his research.
Makes you think how much of scientific success is formal training versus just raw talent and drive. Right?
Definitely a debate worth having. And it's also important to note that Hubble's career got bookended really, by 2 world wars, where he served.
This dedication to service, alongside his scientific pursuits, really paints a picture of a dedicated individual. Now, to understand the full impact of Hubble's discoveries, we have to set the stage. There was this huge debate raging in astronomy at the time about these things called nebulae.
These blurry patches of light seen through telescopes.
Exactly. Fuzzy, undefined shapes amidst the stars.
Mm-hmm.
The big question was, were they just clouds of gas within our galaxy, the Milky Way, or something much grander, what they called island universes?
Entire galaxies just like ours, but impossibly far away.
That was the famous Great Debate, and it involved some big names. On one side, you had Harlow Shapley, Hubble's rival, arguing the Milky Way was the whole universe, and these nebulae were just part of it.
Shapley wasn't totally off, actually. He had a pretty good idea about the Milky Way's size, but his concept of the universe, way too small.
On the other side, you had folks championing these island universes, which was huge E at the time, meant a universe filled with countless galaxies.
And this was all before we could easily measure these vast distances. Time of speculation, big arguments.
And then comes Hubble with his sharp observational skills and this game-changing tool, the 100-inch Hooker telescope at Mount Wilson Observatory, the biggest in the world at the time. Can you imagine the excitement surrounding this thing?
Absolutely transformative for astronomy. And
Yeah.
Hubble was about to use it to settle one of the field's biggest questions.
He sets his sights on the Andromeda Nebula, one of the most prominent ones in the sky.
Trying to find a specific type of star within it called a Cepheid variable.
And these Cepheids are fascinating. They pulsate, right?
Yeah.
With a very regular rhythm.
Like a cosmic heartbeat, dimming and brightening. And the key is how fast or slow this pulsation is directly tells you how bright the star actually is.
So it's like a cosmic clock that also tells you how strong its light source is.
Right. Astronomers call them standard candles because you compare this true brightness to how faint it looks from Earth, and bam, you can calculate the distance.
Like standing on a dark street, seeing 2 identical light bulbs, but one's dimmer. You just know the dimmer one is farther away, right?
Perfect analogy. So Hubble meticulously observes these Cepheids in Andromeda, measuring their pulsation periods.
And what he finds?
Yeah.
Well, it basically rocked the astronomy world. The Cepheids in Andromeda were way dimmer than anyone expected. Much dimmer.
Only one explanation. They were incredibly far away, way farther than the estimated size of the Milky Way itself.
Total game changer. Hubble had proven Andromeda wasn't some nebula in our galaxy, but a separate island universe, millions of light years away.
Just think about that shift in perspective. Overnight, the universe becomes vastly bigger. The Great Debate is settled a universe teeming with galaxies.
Media went wild. Hubble's findings were even on the front page of the New York Times. Instant scientific celebrity.
And this is just the beginning. But before we get into those later discoveries, there's another key contribution of Hubble's, his galaxy classification system.
His famous tuning fork diagram, right? Categorizing galaxies by how they look, bringing order to this new island universe chaos.
Like a literal tuning fork. On the handle, you have elliptical galaxies, smooth and oval-shaped. Then down the two prongs, you get spiral galaxies, those with the beautiful arms. And those were further divided based on if they had a bar-shaped structure in the center.
And then, of course, there were the oddballs, those that didn't fit, which Hubble labeled as irregular galaxies.
Now, it's important to remember he was working with just visible light, no way to study dark matter or how galaxies change over time back then. But even with that, his system was insightful and laid the groundwork for how we classify galaxies even today.
Simple, elegant solution that's still in use. But remember, this was just the start for Hubble. He was just getting warmed up.
Oh, for sure. Because next up is where things get really interesting. We're talking about his work on the expanding universe, the very foundation of the Big Bang Theory.
And that's what we'll pick up in part 2 of our deep dive into the incredible work of Edwin Hubble. Stay tuned. Welcome back. Last time, we left off with Hubble proving those island universes existed, galaxies beyond our own.
Right, settling that huge debate.
Now we're getting into even more groundbreaking stuff. Hubble's work on the expanding universe. This is Big Bang territory, folks.
Foundation of it all, really. But before we dive into Hubble's specific contribution, gotta give credit to Vesto Slipher. American astronomer, made some key observations in the early 1900s that kind of hinted at this whole expanding universe idea.
Okay, so set the scene for us. What was Slipher up to?
He was using this technique called spectroscopy to analyze the light from distant galaxies. Basically, imagine you take starlight and pass it through a prism.
You get a spectrum of colors,
Right.
like a rainbow.
Exactly, a cosmic fingerprint. And within those rainbow-like spectra, Slipher was looking for specific patterns, dark or bright lines corresponding to different elements.
So by analyzing those lines, astronomers could tell what those far-off galaxies were made of.
Right, and Slipher noticed something weird. The lines weren't where they should be, they were shifted.
Shifted? You mean like towards the red end of the spectrum?
Bingo! It's called redshift, and it's related to something you experience all the time, the Doppler effect.
Right.
But with sound waves...
Like when a siren changes pitch as it goes past you. Higher coming towards you, lower going away.
Nailed it. Works similarly with light. Object moving towards us, light waves compress, lines shift towards the blue end. But moving away, light waves stretch. Redshift. And Slipher observed a lot of redshift in those galaxies. Meant they were moving away from us, and fast.
Huge clue that the universe wasn't this static, unchanging thing everyone thought it was.
Huge. Slipher's observations were groundbreaking, but his sample size was small, like 40 galaxies. Hubble, working with his colleague Milton Humason, they took this to a whole new level.
Okay, so who was Humason? What did he bring to the table?
Masters at capturing light from the faintest, most distant galaxies. Perfect skill set for this kind of cosmic detective work.
Dynamic duo, huh?
Absolutely. They gathered tons of data on galaxy distances and their redshifts, and when they plotted it all out, boom, clear pattern emerged.
A pattern that basically changed everything.
The farther away a galaxy is, the faster it seems to be moving away from us. Like dots on an inflating balloon.
Whoa, okay, so everything's moving apart. How do you even wrap your head around that?
It's wild. And this relationship became known as Hubble's law. Simple equation. Velocity equals the Hubble constant times distance.
Hubble constant. Break that down for me.
It's like a measure of how fast the universe is expanding. Their initial calculation wasn't perfect, but the relationship they found, spot on.
So the farther away something is, the faster it's receding from us. Like some kind of universal speed limit.
It's a good way to visualize it, yeah. Now, important to note, Hubble himself was cautious about saying this redshift was only galaxies moving through space. He called them apparent velocities because he knew there might be more to it.
What else could be causing it besides just galaxies flying away?
Well, here's where our understanding has evolved since Hubble's time. We now know it's not the galaxies themselves moving, but the space between them that's expanding. It's space-time itself that's stretching.
Okay, hold on. So not the galaxies moving, but the space between them expanding. That's a mind bender.
Big time. Imagine dots on a balloon. Inflate it. The dots aren't moving across the surface. The surface itself is expanding, making them farther apart. Key difference.
Ah, I see. So the farther light travels, the more its wavelengths get stretched by this expansion, hence the redshift.
Exactly. It's subtle but crucial. Hubble's law, simple as it is, opened up this whole new way of thinking. a dynamic, ever-evolving universe. And that paved the way for the Big Bang.
Makes sense. If it's expanding, go back in time, it must have been smaller and denser, right?
Precisely. Big Bang describes a universe that started super hot, super dense, and expanding and cooling ever since. And Hubble's work on expansion was essential to that.
But knowing Hubble, he wasn't going to stop at just discovering the expanding universe. He always aimed big.
Oh yeah, he was just getting started. Next up, he wanted to figure out, was this distribution of galaxies, like, uniform on the largest scales? Or were there clusters, voids, things that messed with this idea of uniformity?
Okay, now we're getting into some deep cosmology.
It all boils down to something called the cosmological principle.
Lay it on me. What's that all about?
Imagine standing anywhere in the universe, cosmological principle says. No matter where you are, it should look roughly the same in all directions. No center, no special vantage point.
So our little corner of space isn't unique or anything special.
Exactly. Pretty humbling. And it has big implications for how we study the universe. If it's true, the laws of physics should be the same everywhere, so our observations here apply to the whole thing.
Makes sense. So how did Hubble even go about testing something that big?
Data. Tons of it. Hubble launched this massive project to map out the positions and distances of thousands upon thousands of galaxies.
Creating a cosmic map, basically.
Exactly. Meticulously counting galaxies in different parts of the sky, looking for any variations that weren't just random.
And what did he find after all that work, after mapping all those galaxies?
His findings, based on this enormous amount of data, astonishing. The universe on the largest scales was amazingly uniform. Big win for the cosmological principle.
So the simple idea that the universe is the same everywhere, it's actually backed up by observation.
Yep. Of course, things are more complex than that. We know now there are galaxy clusters, voids, variations in density, but those are on smaller scales. Zoom out far enough, just like Hubble's data showed, the universe is incredibly smooth and uniform.
Wow, Hubble's work really shaped how we understand the universe's structure. Truly remarkable. But this story wouldn't be complete without another giant of science, Albert Einstein.
Ah, yes. Their paths intertwine in such a fascinating way. In the final part of our deep dive, we'll explore their meeting at Mount Wilson, Einstein's famous biggest blunder, and the lasting impact of Hubble's work. Stick with us.
And we're back for the final part of our Edwin Hubble deep dive. We've covered his incredible journey, proving those other galaxies existed and then uncovering this whole expanding universe idea.
Monumental stuff, truly.
And now we're adding another layer. The intersection of Hubble's work with, well, one of the most recognizable figures in science, period. Albert Einstein.
Can't get much bigger than that.
Seriously, you hear that name, you instantly picture, like, genius, the guy who revolutionized our understanding of space, time, gravity. So how did these two giants of science, observer and theorist, come together?
So in 1931, Einstein goes on this 2-month visit to Pasadena, California, home to Mount Wilson Observatory, ND Caltech. His goal was to connect with, all the leading astronomers, physicists, and naturally that included Edwin Hubble.
I bet there was a ton of buzz around his visit. Einstein was already a global icon, right? Famous for his theories of relativity and all that.
It's absolutely constantly in the public eye, lectures, interviews, you name it. But despite all that, he was genuinely interested in, engaging with the scientific community, hearing about the latest discoveries.
So picture this. Einstein arrives at Mount Wilson, excited to meet Hubble, see the evidence for this expanding universe firsthand.
Yeah.
What was the dynamic like between them?
Well, you could say there were some personality clashes. Einstein, with his hair, his casual style, kind of the classic image of an absent-minded professor. Hubble, very polished, always that meticulously cultivated British accent.
Oh, yeah, we talked about his Anglophilia. I can see how that might have clashed with Einstein's more down-to-earth vibe.
Some cultural differences there for sure. But more importantly, their views on the universe were, at first, totally opposed. Einstein, he believed in a static, unchanging universe. He even added this fudge factor to his equations.
The cosmological constant, right?
That's it. Meant to counteract gravity's pull and ensure a static universe model. But when faced with Hubble's observations, the actual evidence of expansion, Einstein realized his mistake. The universe wasn't static, it was dynamic, constantly changing.
That meeting between Hubble and Einstein, it really was a turning point for cosmology. The undeniable data, the observations, that's what ultimately changed Einstein's mind.
Perfect example of how theory and observation work together in science, right? Einstein's theories provided the framework, but Hubble's observations forced those theories to, get refined to match reality.
Amazing to think this huge shift in our understanding,
Yeah.
accepting the expanding universe, all because of Hubble's careful observations and Einstein's, his willingness to admit he was wrong.
It led directly to the Big Bang Theory, which is still our most accurate model for the universe's origin and how it all evolved.
Hubble's ambition didn't stop there, though. He wasn't content with just, discovering the expanding universe, always pushing for more.
Remember George Ellery Hale, the visionary who built the Hooker telescope? Well, he had an even grander vision, a telescope twice the size, a 200-inch behemoth that would just completely revolutionize astronomy.
Wait, a 200-inch telescope? That's insane. Where could they even build something that big?
They found the perfect spot on Palomar Mountain in Southern California. Building this thing, which became known as the Hale telescope, was a massive, massive undertaking.
Must have been an engineering marvel, pushing the limits of what was possible back then.
Absolutely, a true testament to human ingenuity. And the project had to overcome a ton of obstacles. Funding shortages during the Depression, delays because of World War II.
But Hubble, always a champion of ambitious science, he was a big advocate for this new telescope, right?
Oh, absolutely. Instrumental in getting support and funding. Sadly, though, his health declined soon after it was completed in 1949. He had a heart attack that really limited his time using this amazing instrument.
It's a reminder that, well, life is fragile, even for giants in their fields like Hubble.
Hmm.
But the Hale telescope became this enduring part of his legacy, allowed astronomers to see deeper into the universe, refine our understanding of, well, everything.
Like a torch being passed, to future generations. And in a way, the same can be said for the Hubble Space Telescope, launched in 1990, named in his honor, of course.
Wow.
Fitting tribute to a man who expanded our cosmic horizons in ways few could imagine.
Incredible how Hubble's legacy is still inspiring scientific exploration. So as we wrap up our deep dive, what are the key takeaways about Edwin Hubble that we should remember?
Well, his groundbreaking discoveries, for sure. Settling that debate about the nature of galaxies, revealing the expansion of the universe, those were game changers, completely revolutionized our understanding of the cosmos.
And we can't forget the man himself. Ambitious, complex, and ultimately a brilliant observer who left a huge mark on science.
I think the most important thing, though, is to remember the impact of his work. The questions he raised, the universe's age, how it evolves, its ultimate fate, those questions are still driving research today.
So next time you look up at the night sky, remember Edwin Hubble and the vast expanding universe he showed us, a universe full of wonder and, well, endless mysteries to uncover.
And who knows, maybe you'll be the one to make the next big discovery that changes our view of it all. The journey continues, and the universe is waiting.
And that concludes our deep dive into the life and work of Edwin Hubble. Thanks for joining us.